on Desmos and just to see what happened. All right, so what it's giving you is a very general equation for an absolute value. Y equals absolute value of x minus some number plus some other number. And it's showing you what happens with these values. So if we were just looking at this value of d, we could use whatever letter we wanted. The letter here is just showing you that there's some variable changing it. If I move d in the positive direction, it moves that graph up. Right? If I move it in the negative direction, it moves that graph down. So if we were building our own absolute value function, y equals absolute value of x plus 4, right? It puts it right up here at 4. That having the absolute value and then a plus or even a minus, it's going to move it down. This is what's changing the vertical. We call this a vertical translation. It's moving the graph up or down. All right, so now let's turn this one off for a second. What if we want to, we don't want to move, we're not changing this value outside of the absolute value. We're looking at this value inside the absolute value. So what happens if we change that? And this is interesting because it does a little bit opposite of what we think. When I say minus a value, it's moving to the left. And when I say plus a value, it's moving to the right. So that value inside, negative moves it to the left, positive value moves it to the right. And it's because it says minus, so it's doing the opposite, right? A negative makes a positive. So that's why it moves in the positive direction when it's negative, and it moves in a negative direction when it's positive. All right, now let's try this value of, oh, and if we wanted to see this, if we moved this minus inside, right now, and we turn this back on, we see that a negative moves it to the right, and if I make that positive, I move it to the left. So I was trying to get you to see that when the number is inside the absolute value, what happens? All right, so let's turn that one back off for a second. What happens when we change this value of a? Well, when a is 1, we have the slope basically being 1, right? The slope of each side, the rate of change of each side is 1. If I make it be 2, well, now I have a slope of 2. Put it back right in the middle. All right, it's going up 2 over 1, up 2 over 1. So that value of a is making it be narrower, narrower. We call that a vertical stretch, because imagine you having your arms up and you're stretching them up higher and higher. And if I make a fraction, so it's not negative yet, right? It's less than 1, but not a negative value. We call this, we have this being a really wide mouth, right? So a fraction of a makes this very wide. And then if we make it a negative a, we have a reflection, so we're turning it upside down. So what I was trying to have you see is that you create these. So if I want to have an upside down v, I'm going to need a negative value, right? And I have it over 3. So if we put this all together, now I'm going to vertically translate it up. So you can see that changing these values, they are very predictable in what they're going to do. So when you see the absolute value, you're going to say, oh, I have a v. When I see the number inside the absolute value, that's shifting it left or right. When I see it outside of the absolute value, that's shifting it up or down. And then this value out in front of the absolute value, that is telling it whether it's going to open up, positive opens up, negative opens down, and how wide the opening is going to be.